Now that we've talked about sets, subsets, and proper subsets, let's go on and look at what it means for two sets to be equal. Let me just say it this way, get right to it. If two sets, we'll call them set A and set B, are equal, the real straight definition of this, I think it makes a whole lot of sense. If they're equal, then all of A is in B, right? And also all of B is in A. Okay, well, if all of A is in B, then we say that A is a subset of B. And if all of B is in A, then we say that B is a subset of A. And that's exactly the definition that we use to say that two sets are equal. We say if A is equal to B, okay, well, let me take a symbol from logic that we just came out of. Then we're saying that A is a subset of B and B subset of A. Okay? Hopefully that makes pretty good sense. Now, we could also, since we've just come out of chapter 2, we could say it using quantifiers. Now, let's build ourselves up to this. So let's just take a break for a second from this idea of equality. Let's go back to this. If we say that A is a subset of B, what we're saying is this statement, A is a subset of B, is logically equivalent to, for every x, for all x, if x is an element of A, then x is an element of B, right? So what would it mean to say that A is not a subset of B? Well, that's just negating the statement where it is not the case that for all x, x is an element of A. If x is an element of A, then x is an element of B. So here we go. If you want to pause the video and go ahead and negate this, just to make sure you remember how this is done, we're going to negate this universal quantifier. We're going to take this negate symbol right out here and we're going to work it through. So if you want to pause the video, go for it. Okay? All right. So we take this negate through, and you know that this now becomes there exists an x where it's not the case that if x is an element of A, then x is an element of B. And now we need to work that negate through this, but we've done this before. Remember, if we're going to negate this, it makes a whole lot more sense if we write this as, instead of the conditional, if we use the disjunction, the or. And remember, it's not x is an element of A or x is an element of B. So now let's carry the negate through. If A is not a subset of B, then there exists an x. Carry this through. You're going to have a double negate, so that's just going to be x is an element of A. And if we take this negate through, what does that do to the disjunction? And conjunction. And then, and it's not the case that x is an element of B. Okay? All right, let's take this one more step. We usually write it this way. If A is not a subset of B, then there exists an x such that x is an element of A, and when we negate this, we go ahead and say x is not an element of B. Hope that makes sense. All right, so there's that practice. Now, with that in mind, let's go back and see what it is we're doing when we say that A is equal to B, right? A equal to B is logically equivalent to A is a subset of B. I put parentheses around that, and B is a subset of A. Okay? Well, if that's the case, then what would that mean to negate that? If A is not equal to B, well, then what we're looking at is we're negating the statement that A is a subset of B and B is a subset of A. Okay, carry this through. It's not the case that A is a subset of B. Carry this through, that negates, that means or. It's not the case that B is a subset of A. Okay, one more step. If A is not equal to B, that's logically equivalent to saying that A is not a subset of B, or B is not a subset of A. And that's what it means for two sets to be equal, and there's a little bit of work with a quantifier. Okay, little review there.